Artificial intelligence is changing rapidly. It's hard to keep up, but one thing is certain, things are about to get really interesting. OpenAI, a leader in AI research, has just unveiled a game-changer function calling. This breakthrough technology is poised to revolutionize the way we interact with computers. Imagine a world where machines understand our commands effortlessly. Picture a future where software writes itself, adapting to our needs in real time. This is the promise of function calling, and it's closer than you might think. In this brave new world, the line between science fiction and reality blurs. Buckle up because things are about to get really exciting. At the heart of every computer program lies a fundamental concept, the function. These are the building blocks of software, the instructions that tell a computer what to do. Think of them as mini programs within a larger program. Each function has a specific purpose, a task it's designed to perform. Let's take a simple example, a function that adds two numbers together. This function takes two numbers as input, performs the addition operation, and then returns the result. It's a simple concept, but incredibly powerful when you consider the vast array of tasks that can be broken down into functions. Functions are the workhorses of the programming world. They handle everything from displaying text on your screen to processing complex calculations behind the scenes. Without functions, software development would be a chaotic mess of tangled code. Functions act as a bridge between human language and the binary code that computers understand. When you click a button on a website, for example, a function is triggered to handle that action. It might retrieve data from a database, process your input, and then update the website accordingly. But functions do more than just translate our commands into machine-readable instructions. They also promote code reusability and modularity. Once a function is written, it can be called upon again and again throughout a program, saving developers countless hours of work. This modularity also makes it easier to maintain and debug code. If a problem arises, developers can isolate the faulty function and fix it without affecting other parts of the program. In essence, functions bring order and efficiency to the complex world of software development. One of the key benefits of using functions is the power of abstraction. By encapsulating complex logic within a function, programmers can shield themselves from the nitty-gritty details. This allows them to focus on the bigger picture, breaking down problems into smaller, more manageable chunks. Imagine trying to build a house without using prefabricated components like doors, windows, or walls. It would be a daunting task, to say the least. Functions are like these prefabricated components in software development. They provide reusable building blocks that simplify the construction process. This abstraction also makes code more readable and understandable for other programmers. By hiding the complexity within functions, the overall structure of the program becomes clearer, making it easier for teams to collaborate and build upon each other's work. In a nutshell, functions are essential for managing complexity and making software development a more efficient and enjoyable process. Section 1. The limits of tradition. Bottlenecks in the code. Traditional function calling, while essential, isn't without its limitations. Think of it like using a paper map in the age of GPS. It gets the job done, but it can be clunky and inefficient. One major bottleneck is the need for explicit programming. Every single step and instruction must be meticulously laid out by the programmer. This can be time-consuming and error-prone, especially for complex tasks. Imagine having to write down every turn, every landmark, every traffic light on your route, instead of simply entering the destination into your GPS. That's the reality for programmers dealing with traditional function calling. Another limitation is the difficulty of handling ambiguity. Computers are notoriously literal creatures. If your instructions aren't perfectly clear and unambiguous, things can go haywire. It's like asking your GPS to take you to the big building with the clock without specifying which city or even which country you're in. Traditional function calling struggles with such ambiguity, often requiring programmers to anticipate and code for every possible scenario. This rigidity can make it challenging to build truly intelligent and adaptable software. Section 2. OpenAI's answer, a new dawn for function calling. OpenAI's groundbreaking approach to function calling promises to shatter these limitations. Imagine a GPS that not only understands your destination but also anticipates your needs, learns from your preferences, and adapts to changing traffic conditions in real time. That's the level of intelligence OpenAI is bringing to function calling. At the heart of this revolution is the use of advanced neural networks. These complex algorithms excel at recognizing patterns, learning from data, and making predictions. By applying these capabilities to function calling, OpenAI is essentially teaching computers to code more like humans do. Instead of requiring explicit programming for every step, OpenAI's method allows programmers to define high-level goals and constraints. The neural network then figures out the optimal sequence of functions to achieve those goals, learning and adapting along the way. This opens up a world of possibilities for software development. Imagine being able to describe a task to your computer in plain English and have it generate the necessary code automatically. That's the power of OpenAI's function calling. Section 3. The neural network advantage. Learning to code like never before. OpenAI's neural networks are trained on massive datasets of code, allowing them to develop a deep understanding of programming languages and software development best practices. This training process is akin to a digital apprenticeship, where the neural network learns by observing and mimicking expert programmers. As the neural network processes more code, it gets better at recognizing patterns, identifying errors, and generating efficient and elegant solutions. It's like a master craftsman honing their skills over years of practice, constantly refining their techniques and developing an intuitive grasp of their craft. This ability to learn from data is what sets OpenAI's function calling apart from traditional methods. It's no longer about painstakingly programming every detail, but rather about guiding the neural network to learn and adapt, becoming a powerful ally in the software development process. The implications of this technology are far-reaching, potentially transforming the way we build and interact with software in the years to come. OpenAI's function calling might seem like magic, but under the hood, it's a sophisticated blend of cutting-edge technology and clever engineering. Imagine a vast network of interconnected nodes, each representing a tiny piece of computational logic, working in harmony to decipher your commands and translate them into executable code. That's the essence of OpenAI's neural network architecture, a digital brain specifically designed for the complexities of function calling. Unlike traditional programs that follow a rigid set of rules, this neural network learns from data, adapting and evolving its approach over time. It's like the difference between memorizing a phone book and understanding the underlying structure of language. OpenAI's function calling doesn't just follow instructions, it comprehends the intent behind them, paving the way for a more intuitive and powerful form of programming. This paradigm shift from explicit programming to implicit learning is the key to unlocking the full potential of AI in software development. By training neural networks on massive datasets of code, OpenAI is essentially creating a new breed of programmers, digital prodigies capable of outperforming their human counterparts in terms of speed, efficiency, and even creativity. The training process for OpenAI's function calling is akin to teaching a musical prodigy to compose a symphony. Just as a young Mozart would have studied the works of master composers, absorbing their techniques and styles, OpenAI's neural networks are fed a rich diet of code, learning the nuances of different programming languages and the art of crafting elegant and efficient software. This massive dataset of code acts as the training ground for the neural network, allowing it to identify patterns, recognize best practices, and develop a deep understanding of how software works. Through a process called backpropagation, the network fine-tunes its internal connections, adjusting its weights and biases to minimize errors and improve its performance. Imagine a conductor guiding an orchestra, refining their every note and nuance until they achieve perfect harmony. That's the role of the training algorithms in shaping OpenAI's function calling, molding it from a digital novice into a master craftsman of code. This iterative process of learning and refinement is crucial to the success of OpenAI's function calling, allowing it to achieve levels of accuracy and efficiency that were previously unimaginable. Neural networks, the driving force behind OpenAI's function calling, are often shrouded in a veil of technical jargon and complex mathematics. But at their core, they are surprisingly intuitive structures, inspired by the interconnected neurons in our own brains. Imagine a network of interconnected nodes, each representing a simple computational unit capable of processing information and passing signals to its neighbors. These connections, like the synapses in our brains, have varying strengths determining how much influence one neuron has over another. During the training process, these connection strengths are adjusted, allowing the network to learn and adapt to new information. Think of it like strengthening a muscle through exercise. The more you use a particular connection, the stronger it becomes, making the network more efficient at processing similar information in the future. This ability to learn from data is what sets neural networks apart from traditional computer programs, which rely on explicit instructions for every task. OpenAI's function calling leverages this learning capability to revolutionize software development, enabling computers to write code, adapt to changing requirements, and even come up with novel solutions, all while guided by the vast knowledge embedded within their neural networks. The GPT-4 factor, a quantum leap in AI capability. While OpenAI's function calling represents a significant leap forward, it's the integration with GPT-4 that truly unlocks its transformative potential. Imagine combining the architectural brilliance of a master builder with the artistic genius of Michelangelo. That's the level of synergy we're talking about. GPT-4, with its unparalleled ability to understand and generate human-like text, acts as the creative spark, breathing life into the blueprints drawn by OpenAI's function calling. Imagine describing a software application to GPT-4, not in the rigid syntax of a programming language, but in the fluid, nuanced way you'd explain it to a colleague. You convey your vision, the features, the functionality, the user experience you want to create. GPT-4, with its deep understanding of human language and its ability to reason contextually, grasps not just your words, but the intent behind them. It becomes your AI collaborator, a digital Da Vinci, translating your ideas into a symphony of code. This is not just about automating mundane coding tasks. It's about augmenting human creativity, empowering us to build software experiences that were previously unimaginable. GPT-4's ability to generate different code variations, each tailored to specific parameters and constraints, opens up a world of possibilities for software development. It's like having a team of expert programmers at your fingertips, each offering a unique perspective and skill set, all working in unison to bring your vision to life. Case in point, from idea to app powered by AI. Let's say you're an entrepreneur with a brilliant idea for a language learning app. You envision a platform that adapts to individual learning styles, provides real-time feedback, and gamifies the learning process to keep users engaged. In the past, turning this vision into reality would have required a team of developers, months of development time, and a hefty budget. With OpenAI's function calling and GPT-4, the process becomes dramatically simplified. You describe your vision to GPT-4, outlining the key features and functionality. GPT-4, leveraging OpenAI's function calling, doesn't just generate lines of code, it constructs the underlying architecture of your app, selecting and integrating pre-built modules and even writing custom code where necessary. It's like having an AI architect, designer, and developer all rolled into one, working tirelessly to bring your vision to life. Within hours, GPT-4 presents you with a functional prototype ready for testing and refinement. You provide feedback, suggesting improvements and tweaking features. GPT-4, with its ability to learn and adapt, incorporates your feedback, iterating on the design and functionality until your vision is fully realized. The entire process, from idea to app, is streamlined, accelerated, and significantly more cost-effective. This is just one example of the transformative power of OpenAI's function calling and GPT-4. This potent combination has the potential to democratize software development, empowering individuals and small businesses to create sophisticated applications that were once the exclusive domain of large corporations with deep pockets. Rewriting the rules, the profound impact of OpenAI's innovation. OpenAI's function calling, particularly when coupled with the prowess of GPT-4, is not just an incremental step in software development, it's a seismic shift, a fundamental reimagining of how we interact with and harness the power of computers. The traditional barriers to entry in the world of software development, the steep learning curve, the time-consuming coding, the need for specialized expertise are being lowered, opening up a world of possibilities for individuals and businesses alike. Imagine a future where the ability to code is no longer a specialized skill confined to a select few, but a widely accessible tool for creation and innovation. This is the promise of OpenAI's function calling, a future where the power to translate ideas into software is democratized, empowering anyone with the vision to bring it to life. The implications extend far beyond the realm of software development, from automating complex tasks in scientific research to personalizing education through AI-powered tutors. The applications of OpenAI's technology are as diverse as the human imagination itself. This is not just about making our lives easier, it's about expanding the boundaries of what's possible, unlocking new frontiers of human ingenuity and creativity. Embracing the future. A call to action in the age of AI. As we stand on the cusp of this exciting new era, it's imperative that we approach these advancements with a sense of responsibility and a commitment to harnessing their power for the betterment of humanity. The future we create will be shaped not just by the capabilities of AI, but by the choices we make today. Let us embrace the transformative potential of OpenAI's function calling and GPT-4, not with fear or trepidation, but with a spirit of curiosity and a determination to shape this technology into a force for good. The future is unwritten and the pen, or rather the keyboard, is in our hands. Let us use this newfound power wisely to build a future where technology empowers, not enslaves, where innovation benefits all of humanity, and where the only limit to what we can achieve is the scope of our collective imagination. The journey into the age of AI has just begun, and it's up to us to ensure that it's a journey worth taking.